Okay, in the last video I showed you that the acceleration of this system is g divided by 1 plus r1 squared over 2r2 squared. Okay, let me just double check that. Oh, indeed, that is the correct answer. Okay, 1 plus r1 squared over 2r2 squared. Okay, now I'm going to show you how to do that using energy. Now the trick we're going to use is this. We're going to presuppose that it falls from rest. This doesn't matter whether it starts from rest or not, right? But if it were to fall from rest, right, remember that v squared is u squared plus 2as. If it falls from rest, that's 0. If it falls a distance h, that's h, right? So ultimately we have that v squared is 2ah. So a is just simply v squared over 2h. If in my energy expression, and I will arrive at this, right, at a formula for v squared, if I divide by 2h, I'll have a formula for a. Somehow I'll get this. Seems implausible, but let's do it, right? Okay. This was at least somewhat complex to come by, but for energy, I think it's not so hard, okay? So this yo-yo, it's a yo-yo, okay? This yo-yo is got potential energy, right? So it's just mgh, okay? And then right before it hits the ground, it has, of course, it's got linear kinetic energy, and it has rotational kinetic energy, right? And I'll do the same, the standard substitutions, right? I am going to assume is 1/2 mr squared, that's an r. And we'll assume that the omega is linear velocity divided by, well, in this case, really, it's this small radius that the string is wrapped around, right? Okay. So this is R1. This is R2. That will matter here in a moment. Okay, so let's plug that in. Thank you. All right, mgh is 1/2 mv squared plus 1/2 m, and then I have to use the whole radius here, so r1, and then this is going to be v over r2 squared, right? And that's squared. So remember that if this thing's moving at some linear velocity, it's angular velocity, and that's why yo-yos spin so fast, right? Is that it's wrapped around that tiny little radius there, okay? The tinier that is, the faster the yo-yo spins, right? So there's some ratio going on here. Okay. Okay, so let's let the dust settle here. So let's go. mgh is 1/2 mv squared, and then 1/2 and 1/2 is 1/4, right? And then the r's don't cancel because they're different radiuses, right? So we've got r1 squared over r2 squared, right, times v squared. Okay, the phone's ringing. I can't answer the phone. All right. Now at this point, I'm gonna cancel all the masses, right? So I'm canceling that mass. We end up with gh is equal to 1/2 v squared, right, plus 1/4 r1 squared over r2 squared v squared, right? Now my next step is to factor out the v squareds, right? So v squared outside of 1/2 plus 1/4 r1 squared over r2 squared. Okay, so now I'm going to go v squared equals gh all over 1/2 plus 1/4 r1 squared over r2 squared. Yeah? Okay, now, drum roll please. Once you get to v squared, don't solve for v, right? We just want a. So a, if we divide that by 2h, right, I'm going to get a value for a. Okay, so the h cancels the h, right? Okay, that makes it A. Okay, so A is going to be that, right? Okay, and then if I just multiply the denominator by 2, I get G divided by, well, 2 times a half is 1. 2 times a quarter is 1/2, right? Okay, pretty sure that we just got this, right? I think that's simple, right? It's like that, right? You do have to be clever about the radiuses, but you had to be clever about that anyway, right? Anyway, happy hunting. I hope that helps.